Hi all. Today let's see how we can improve or maintain the performance of our Angular application. So today's topic we will be seeing the importance of why we need to unsubscribe from observables whenever a component is destroyed. So for demonstrating this, I have created an Angular 13 application. So let's go through the application. So this is the app component.html. Within this, I have a child component called app_child, which basically I will be toggling through the click of this button. So inside the button click, I am just toggling the Boolean flag, which is attached to the ngIf of the app child. So if you go to the application, this is the view of our application. So we have this button and this is the child component. So one thing to note is that within the child component, what is happening is I have implemented the onInit lifecycle hook, and within the onInit lifecycle, what I am doing is I am basically calling an API. So I have created a shared service within which I have the method getData, and inside that I am making a call to a predefined API. So here I am subscribing to that getData method so that the observable will actually get executed, and we are displaying the data which we receive from that API in the console. So whenever this component is created, it will be calling this API and logging the data. So now let's run the application. So initial load, when the child is created, you can see that if you check the network tab, you can see the XHR call going and the response is received. And as soon as the response is received, we will be consoling the data. Now, whenever we destroy and again create the component, you can see that immediately the API is called and the data is logged. So here you would have noted that within my child component, I am just subscribing to this API call and I am not actually unsubscribing. So you would think why it didn't lead to memory leak. So what is meant by memory leak and how we can identify that? So let's see that. So for identifying memory leak, we can make use of the memory tab within our Chrome Devtools. Here we have multiple options. One is take the heap snapshot, which will show a snapshot of our memory. So this button helps us to collect the garbage, that is collect objects which are no longer used. And if we click here, we will be able to see the size of the memory that is consumed by our application. So in order to take a heap snapshot, we need to press on this button. So I am pressing on this. If we need to see whether the child component, that is the component in which we are making use of the subscription, it is actually getting garbage collected or it is getting destroyed from the memory, we can make use of this technique. So initially we took the snapshot, now we are destroying it, and now again we are creating it. So here click on the garbage collector one more time and take one more snapshot. So here you can see that actually the snapshot size is exactly the same. So if you click on a snapshot, there are different views which are available. So one is the summary, which will display all the items which are available currently within this memory snapshot. So here you have the different objects, the different arrays. Similarly, if we check for the child component, that is our component, you can see that there is a single instance of that. And here you will be able to see what are the different values which are available within that child component. If you expand this, how can we see whether that child component actually got destroyed? So there is an option to compare here. So we should select the comparison. And if we compare with the snapshot 1, here you can see that actually a new component was created, and when it was destroyed, it was deleted. And now the effective delta between the new and deleted is 0. So basically the component was destroyed and there was no memory leak. Similarly, there is another option which we can use, that is the second option, allocation instrumentation on timeline. So what this does is we can start recording the heap profile. So whenever we do an action, you can see that the memory is spiking. So now we have created the component back. So we can stop recording and you can select the timeline which passed through here. And in case you search for the child component, you can see that only a single child component instance is currently available, that is which is present now. So now we saw that there is no memory leak currently within our application, but even though we did not unsubscribe from this particular observable, which is actually making an HTTP code, it did not lead to memory leakage even though I did not unsubscribe. So why this is happening is, if you check the Angular code for making the HTTP, as HTTP client get or any other HTTP methods, you can see here that once the result is coming back, the observer emits the value that is received from the API and immediately it will complete the observable. So this is the reason why we do not need to unsubscribe from HTTP based observables. So now let's see another scenario in which we will be making use of a rxjs subject within the service and we will be subscribing to that. So in this second example, what I have done is that within the shared service.ts, instead of directly returning the observable that I receive from the HTTP call, what I am doing is I have created a new subject here, that is a send data $, and from that subject I have created an observable. So that is this publicly exposed observable. And similarly I have added a method also which can be used for sending out the data from this subject. So within the getData method, previously I was directly returning the observable from the HTTP get. But here what I am doing is I am making the HTTP get call and to that I am subscribing. And within that, basically I am getting the data and I am pushing that data through the rxjs subject. So within the component, I will be listening to the publicly exposed observable. And here, basically I am doing the same thing. I am getting the data and logging it in the console. And also I am attaching the data to this data property, which I am binding in the HTML. So now let's see what happens. So here I am refreshing the application. So here you can see that initially the data which you receive from the API, that is getting displayed here and also logging in the console. So now what I'm going to do is I am going to destroy the child component and recreate it. So now you can see that here actually two console messages were logged. Why this happened? In case I clicked one more time and created the child one more time, you can see that it is keeping on growing. So similarly, the next time it will be 4. So this is a clear indication of memory leakage within our application. So what is happening is that even though our child component, it is getting destroyed and removed from the view, actually that component is still existing within our memory. So because of that, what happens is that the subscription which we created within the child component, it is still open since it is existing in the memory. So because of that, all the components which make use of this subscription. Like it is actually blocking the removal of this component from within the memory. Problem with this kind of memory leakage is that here actually I am just logging a console. But in case I am performing a performance heavy action like making an API call or something like that. So what will happen is that each time whenever a new leak is created, like here currently there are 4 active connections. So in case I am calling an API, it will be executed 4 times. And also the memory size will keep on increasing, and effectively our application will become slow and may ultimately crash. Here, since we had this console, we were able to identify that there was a memory leak. Now let's see how we can identify that through the memory tool. So let's try to find out the memory leak by making use of the memory tool within the Chrome Devtools. So initially I am making use of the heap snapshot method. So while making use of the heap snapshot, so here our main culprit is the child component, since that's the only component which actually has some logic within it. So here what we need to do is that initially I will destroy this child component. So currently if I do a memory dump, our child component should not be there within our memory. And here again we are creating the child component, and when I click one more time, the child component will be destroyed. So at this particular time, again I will be taking a snapshot. So ideally the memory size should be exactly same to what it was previously. But here you can see that actually there has been an increase within the memory size. So here again we can make use of the comparison method, and in case we search for our child component, you can see that actually a new component was created, but it was not destroyed. So basically a component is still there within our memory. And here again if we try to perform the same action one more time and again take another snapshot, you can see that actually the size is consistently increasing. And if we compare this with our initial snapshot, that snapshot 1, here we can change the snapshots. So here I am comparing with the snapshot 1, and here you can see that actually there are 2 child components within our memory and it is not getting destroyed. So this is one way in which we can identify memory leaks. Also here you can check for the subscription. Here again you can see that there are 2 active subscriptions within the memory, even though our component is not there in the view. So ideally, in case it was there in the view, there would have been 3 subscriptions. So when we click on the subscription, you can see the flow, ideally how this subscription is getting used. So if you go here, you can see that this is the shared service, and we have the send data subject which we have exposed, and we are effectively consuming that within our child component. So this way we will be able to track where the active subscription is present. Similarly, if you click on the next instance, again you can see that it is the second child component instance. So since this subscription is not getting closed, our child component and all the related parents will not be destroyed from the memory. So as a result of that, the memory size keeps on increasing, and in case I continue going on like this, since it is a very small application, the memory size won't be much of a problem, but it will keep on increasing for a large application. Now let's see another way in which we will be able to identify the memory leak. I have refreshed the application. So I'll make use of the second option, allocation instrumentation, and I am going to click the profiling. So I am going to do some actions. So effectively I have clicked 3 times on the toggle child, and ideally 3 child components should be there within our memory. So here I am going to select the timeline, and in case I search for the child component. You can see that two child components are there within our memory. And similarly, two subscriptions as well will be present. So this is another way in which we will be able to identify memory leak within our application. So now let's see what are the different ways in which we can unsubscribe from an observable so that we can prevent the leakage of memory. So the first option is that whenever we subscribe to an observable, we will be receiving something called a subscription. So we can directly assign that value which is returned from this subscribe to the subscription. The type will be an rxjs subscription. So once we assign this value, what we need to do is that since we are subscribing within the component, we need to implement the onDestroy lifecycle hook. We need to create the ng-onDestroy method. Within this, we can add a check whether the subscription is present. In case it is present, we can call the unsubscribe method from within the subscription. So now let's see what happens in our application. So here I am refreshing the application. So initially one call is going. Next time I am toggling and creating the child. Now you can see that only one call is going again. So our subscription is getting handled, and every time the component gets destroyed, this particular line is getting executed. So here we can just confirm that. So I am going to toggle that. So ideally the child component is destroyed. So here we have a subscription and it is not yet closed. So here I am going to unsubscribe that. Now you can see that it is closed and there won't be any more open connection within our component, and it can be completely destroyed from memory. And the next time we create here, when we subscribe, till now it is undefined. When we do a subscription, again that connection is opened and we get the handle to that subscription. Now let's take a look at another way in which we will be able to unsubscribe from an observable. So here we are not making use of the subscription handler. Instead, we are going to make use of the takeUntil operator. So it basically means that to this takeUntil operator, we are passing an observable. So in this case, it's a subject, and this particular connection which we are establishing with our subject, which is within our shared service, that will be active only as long as this particular observable is active. In case this is closed, this connection also will be closed. So let's see how we can implement that. So first we need to create a new subject, and I am passing that subject to the takeUntil. So here I am making use of the pipe operator, and I pass the takeUntil operator to within that pipe, and this particular observable I am subscribing. So now in the ng-onDestroy, here what I am doing is that I am checking the closer subject is available. In case it is available, we need to emit a value, and after that we need to unsubscribe. Okay, so let's see what happens in case I did not emit this value. So here when I toggle, you can see that still the memory leak is present. So that is the importance of emitting this value from within the closer subject. So in case we activate the next, you can see that there is no memory leakage and it is working as expected. And also we can call the complete, which has the same effect as unsubscribing. So here you can see that the memory leak is not present. So in the example which we are currently looking, you can see that actually I am directly binding the data which we receive from the observable to the HTML. So in this scenario, I can make use of the async pipe as well. So here what I have done is I have created a publicly exposed observable, that is data dollar, and here I am directly assigning the send data observable which we are receiving from the service directly to this property. And here within our child component HTML, I am binding the observable along with the async pipe. Now, in order to log the message, what I have done is that I have added a pipe and the tap operator in which I am logging the console. So now let's see what happens. So I am refreshing the application. So initially one time the message is logged, and now you can see that when I delete and recreate, only a single execution happens and there is no memory leak. So the async pipe automatically handles the unsubscription of observables since it is bound in the HTML. Now let's see one final option in which here I am going to create a base class called the base component, and all the components within the application will be extending from this particular base component. So the main aim for creating the base component is that we are going to implement the automatic unsubscription of our observables within this base component, and the developer need not worry about unsubscribing and handling all those kind of things. So here what we are going to do is that the base component is basically a abstract class and we need to provide a decorator, Angular decorator. So here I am giving the directive empty without any selector, and here we will be implementing the onDestroy lifecycle hook. So within the ng onDestroy, what we will be doing is that this base component will have a list of subscription, and here we expose a method called handle subscription which will accept an observable source and a corresponding handler. So in the child component, if you see, I have extended the base component, and since we extend the base component, we need to call the super, and after that, instead of directly subscribing to our observable, what I am doing is I will be calling the handle subscription method which is present within the base class. So here inside this subscription, I am passing the source, that is the observable, and the corresponding handler, which is the code we need to execute. So here we are not directly subscribing, and the developer can just call this method and need not worry about unsubscribing from the observable. So within the subscription, what we are doing is that we are subscribing to the source and adding the handler, and here automatically we will be pushing the subscription which you receive from this subscribe to this subscription list. And when this particular component is getting destroyed, we will be looping through all these subscriptions and call the unsubscribe method. So effectively all the subscriptions will be closed when the particular component will be destroyed. So now let's see this in action. So initially our API is called and the data is displayed. So the next time you can see that the subscription is automatically unsubscribed and we need not worry about whether there will be any memory leakage within our application. Hope you are able to get a good idea about what are the different ways in which we can unsubscribe from an observable and how to prevent memory leakage within our application so that our application remains performant. See you soon. Thank you.